Hi friends, welcome to yet another video where we are solving some of the problems from mechanics of materials or mechanics of solids. Here in this particular problem we have a bar as shown in the figure, and at the end there is a weight of 900 Newton hang to it. We are asked to find the maximum stress in the bar. So first of all, in order to predict the maximum stress in the bar, we need to formulate an expression for stress which will capture the variation of the stress along the length of the bar. For that thing, let me define a coordinate system like this. Okay, let me define it from the top itself. Okay, so this is my coordinate system x, which is positive downwards. So I need to calculate sigma of x, or how stress, uniaxial stress. For that I will give a substrate sigma x also, as it is acting in the x direction, how sigma x is varying with respect to the length. So that's what we need to calculate. So as I used to say all the time, the best way to calculate stress at a section is to find out the force acting at that particular section. The best way to find the force acting at a particular section is to draw a free body diagram. Make sense? Good. So let's say I'm considering this section at a distance of little x. Then this will be of length 30 minus x, because the total length is 30, so the remaining length of the portion is 30 minus x. And here I have some 900 Newton force acting, and here will be the net. Since I have cut a section, there will be a net force acting at that section. Let me call that net reaction force acting at that section. Let me call it capital N. Here they are acting equal and opposite. So my focus is on this particular section. So if I draw the free body diagram of the second portion, it will look something like this. Let me elaborate what are these forces. This 900 Newton is the external force, and this particular force which is acting at the center of this particular portion is the weight. It is its self weight. So let's say gamma is the specific weight and A is the area of cross section of the particular bar. We assume that this particular area of cross section remains the same throughout the length. It is not varying with respect to x, or the bar is having a uniform area of cross section. Having established the force diagram or the free body diagram, now things are fairly easy. Now if I sum up the forces in the x direction, I should have my capital N equal to the summation of these two forces, because every single portion in my structure is at rest. It's not moving. So that means I should have a zero resultant force along my y direction. So that means this is the net reaction force acting at that particular section. Now the stress will be the force divided by area. You can see simple maths. You know the specific weight of steel. Density of steel, you can assume a value of 7,800 kilogram per meter cube. From this you can calculate what is specific weight, and you can plug in those values right here in this equation. And in the problem it is given that the bar is of diameter 6 mm, so area can be easily calculated using the expression of pi by 4 d square. Once you add these two things, then from the self weight, let me explain it completely. They are asking you to compute the maximum stress. So this is the expression of the stress, or the variation of the stress goes like this, where let me draw it that once again here. So for that, let me remove this whole thing. See, x is defined from the top of the bar, and for a moment just have a look at that particular expression and come up with an answer at what value of x will be that expression assuming a maximum value. So this is how everything looks like. Apologies for the poor drawing, but my x is defined from here. So this is pretty obvious that for a value of x equal to 0, our stress assumes a maximum value, because you plug in any other value of x, the stress will be less. You can physically appreciate this as well. You consider a section somewhere here, then what is the force acting on it? Weight of this particular portion and this extra point load of 900 Newton. Once you consider a section here, then you have mass of this whole bar till here plus that pointed load. So as you move up and up and up, the net force acting on the section increases. That means the stress at that particular section increases. So your equation makes sense. We are expecting a high stress around this point. So that stress value you can easily compute once you plug in x equal to 0 in this particular expression, and the value will be around 34.14 megapascal, where the bulk of the contribution is from the point load, and there is a contribution of 2 megapascal from the self weight of the bar. So once again, thanks for watching.